Hey everyone, welcome back again to H.S.P and World of Chemistry. My dear students, if you really want to gain 100% marks in chemistry for Neet 2026, then these 7 to 8 minutes are for you kids. Just focus on whatever I'm going to tell you, whatever I'm going to give you, chapter wise, according to NCERT chapters, and what is missing in NCERT, that also I'm going to give you, my dear students. And the most important thing is the sequence. Because right now, I'm not just giving you whatever is required for 100% marks in chemistry. If you are going to follow this chemistry sequence, you're definitely for 20 marks in physics and 10 marks in bio, you will get from here. Not only full marks in chemistry, along with full marks in chemistry, you will get in physics as well as in your bio also. Let's see first the atomic structure. Now you see common path for physics and chemistry. Modern physics, if I talk about modern physics, Bohr's theory, that is common, my dear students. If you do it in chemistry, you will get marks in physics as well. So what is required? Not the whole atomic structure. Let me tell you what is very, very important. That Bohr's model. You should have very good command on Bohr's model, the orbits, and you should remember the energy of first, second, and third orbit. Remember that for hydrogen atom. The jump, the spectral lines, and then your quantum numbers and radial notes, and then, yes, graphs for psi and psi square. But for 1s, 2s, 3s, 2p, and 3s, it's written 3s once again. That should be your 3p. Here it should be your 3p. My dear friends, these graphs are very, very important for Schrodinger's graph this year. Definitely the paper will be on tougher side, but not from, means not out of the NCERT. It will be from your NCERT, and definitely this time they will give these graphs based on Schrodinger, the graph based on psi and psi square for 1s, 2s, 3s, 2p, and 3p. Quantum number, you know very well, spectral lines, you know very well. So this year, remember that, these graphs. Now, second slide is indicating mole concept. In mole concept, you should have very, very basic knowledge about AMU, that is your U, Dalton's number, and then the concentration terms, molarity, molality, normality, formality. But the main concentration is molarity. You should have proper visualization of molarity. What will happen if we are adding water to it? What will happen if we are going to mix it? So my dear students, this concentration, in this concentration term, the main part I would like to focus on molarity. Molarity is the most important. You should have visualization of dilution law for molarity. Now stoichiometry and LOC is law of chemical equivalence. This law of chemical equivalence holds a hell lot of weightage in entire chemistry. In redox you will see everywhere it will come again and again. And this indicates simply milli-equivalents and equivalents. You can simply recall it that normality is equal to molarity into n factor. You can call it valence factor. So n factor is the main prime focus here. Should be that on n factor. Now, my dear students, this video is very short and precise. Okay, remember that. Now, my dear students, equilibrium. So if I talk about equilibrium, so see, first of all, these parts are generally missing in our studies. Whenever you are going to complete the syllabus, remember this point, that this should be the part of your syllabus, that titration, solubility product, and its application in salt analysis. This is the main backbone of this year. Definitely maximum questions will come from salt analysis. So remember that. Here is the brainy logic involved for salt analysis, and it's very simple. Characteristic of K equilibrium, Le Chatelier's pH calculation, buffer. Now pH calculation of strong acid, weak acid, 10 raised to power minus 8 molar HCl1, or buffer solution, salt hydrolysis, salt test. So this is very simple. This is the main part. This part is generally missing in everyone's study. So remember that. It should be there. Now, my dear students, biomolecules. Now, this biomolecules will give you marks in chemistry. Along with chemistry, you are going to get, yes, in your bio also, right? The structures which are missing in bio, they are given over here. The biology part which is missing over here, that is given in bio. Both the way it's going to get benefited. Remember that glucose plays very, very important. 80% part of biomolecules you can do by yourself if you know the structure of glucose, that Hayward's representation, ring, pyranose, furanose form, right? Now, fructose and all reactions and amino acid. Remember that the amino acids, which are really very, very important, essential amino acids, 10 essential, their structure you should know. And DNA, RNA, so you know very well, so no worries. So biology as well as in chemistry, it's equally important. Now comes the thermodynamics, which we can say the backbone of whole chemistry. And this thermodynamics is not only in chemistry, this is in physics as well. That's why in the starting I have told you, if you are preparing for 100% marks in chemistry, you are going to get at least 20 marks in your physics as well. Physics as well, my dear students. So in thermodynamics, remember that this Gibbs-Helmholtz equation, which is equally important in chemistry, in physics, as well as in biology also. A tough question is coming in biology, you know, this Gibbs-Helmholtz equation is involved over there, the logical thinking. Now, this though everyone knows, the visualization of gas laws, Boyle's law, Charles' law, their visualization, PV is equal to nRT, how it is going to work when one thing is constant, how they are working, the graphical representation. Gas law is not in syllabus, but gas law is important for thermodynamics. And then thermodynamics, it's very simple. You have to focus on work done by the system, work done on the system, reversibly and irreversibly, their comparison, and in which process maximum work is done, and their increasing or decreasing order of work done, mainly for isothermal and adiabatic. And once you are going to deal with the heat capacity will come automatically. Heat capacity is the part of it. So if I talk about the whole chapter, thermodynamic heat capacity should be there in your brain. You can't do anything without heat capacity. That is the main part of this chapter, heat capacity. Now, entropy gives free energy, enthalpy application, this everyone knows. And thermodynamics plus redox, you will get maximum part of inorganic done by these two. Logical thinking, no need of cramming. If you apply thermodynamics and redox, you can solve your inorganic chemistry. It will become easy peasy lemon squeezy. Now, my dear students, enthalpy, if you are doing enthalpy, the thermochemistry part will be super easy, right, my dear students? Now, next, purification of organic compounds. Generally, whenever we are preparing at the last moment, we are forgetting this thing. So definitely two questions will come from the combination of this. This though I can say this time you can see 2 to 4 questions from this part, 2 to 4 questions, my dear students, from here, and definitely one question from this Geldal or chromatography. You will get from this one question and one question. My God, that means at least 3 questions you will get, and maximum 6 questions you can get from this portion. And most of the students, 99% students, they're forgetting these 2 chapters. You can't move ahead in your any process of writing any examination without these 2. Salt analysis, my dear students, this holds a hell lot of weightage, and it's very basic. You are preparing it from your class 10th and 11th and 12th. You can't go and you can't write your exam without these radicals. They are fundamental things. You should know what type of gas will get evolved, what litmus paper it is going to convert, what into what, blue to red, red to blue, or the KMNO4 color will dechlorize, or potassium dichromate will change into green or not, how to identify in between carbonate and sulfide, because both of them, they are going to evolve, one carbon dioxide gas, another one sulfur dioxide, and both will convert lime water milky. Then how to find out? Are you getting my point? And these basic radicals, their hydroxides color, whether their hydroxides are soluble or insoluble in excess of ammonium or sodium hydroxide. I think this much is okay. Now, periodic table, chemical bonding, GOC. Why I have written all three on the same page? Once you do periodic table, in periodic table, just find out effective nuclear charge. Once you got the Z effective, once the Z effective is clear, atomic size is clear, ionic radii is clear, ionization energy will get clear, electron gain enthalpy will get clear, everything will get clear. Just in the periodic table, you should know which element is placed where, that exact position should be there in your hippocampus. Then just apply this. Once this is clear, come to the steric number. Once the periodic table is clear, come to the chemical bonding, steric number, then hybridization, then shape, then dipole moment, and then Fajan's rule and bond angle. Sorted. Once you have done all these things, these two things, then only go to the GOC, organic chemistry. This is a sequence which holds a whole lot of weightage, my dear students. Remember, the sequence will play very, very important role. Now in GOC, your resonance mesomeric effect is given over here. But to understand the resonance, you should know first inductive effect, then hyperconjugation, and then resonance. And that is separate by IUPAC, everyone knows, GI, everyone knows, but tautomerism is structural isomerism. The main part is being tautomerism. That's very, very important. Now, optical isomerism also very, very important. Now, once you have got all three, now main focus is to apply these three effects on five things: carbocation stability, carbon stability, free radical stability, acidic strength, basic strength, and aromaticity. These three and these three, five things. The application, right? Now, once this got clear, my dear students, come to the next page. Hydrocarbons, haloalkanes, haloarenes, alcohol, phenol, ether, aldehyde, ketones, amines, everywhere the preparation and the chemical property along with the physical property. I will make one video how to find out the boiling point and melting point of any compound, that I will let you know. But everywhere the physical and chemical properties, but along with those two, where is our prime function to keep it in our brain, that in alkanes the main thing is FRSR, how to that will come in your brain by seeing the simple reaction that FRSR will take place. So remember that that is either UV rays or any thermally or photochemically, that is 500-400 degrees Celsius, that is an indication of FRSR. Now alkenes and alkynes, they are unsaturated, so our brain should say if anything is unsaturated, so we have to think about EAR, electrophilic addition reaction. Whenever electrophilic addition reaction is coming, our brain should talk about that Markovnikov, anti-Markovnikov addition, syn or anti-addition, all these halogenation, hydrohalogenation, and water addition. If I talk about water addition, then three things are there. Simple, that is acidic hydration, or Markovnikov or anti-Markovnikov, or brown hydroboration, that is anti-Markovnikov. Whenever halogenation is coming, anti-addition is taking place, hydrohalogenation is coming place, then what? If any electrophile is having lone pair, then anti-addition. So you have to think about whether anti-elimination is taking place or not. So prime focus should be anti-addition. Anti-addition, whether it is going to take place or not. By keeping this thing that anti-addition is taking place or not, you should remember one more thing: Markovnikov or anti-Markovnikov, Markov or anti-Markovnikov, that thing. Now, once this is coming, haloalkanes and haloarenes. So I have given one memory chart to find out SN1, SN2, E1, E2, ARSN2, substitution versus elimination, that will proceed simultaneously. And if we talk about halobenzene, then ESR, electrophilic substitution reaction, and Williamson synthesis is the main backbone of this chapter. Otherwise, Finkel reaction, Schwarz reaction, they are simple. If we talk about preparation of them, that diazo chart, that your Sandmeyer reaction, that your Gutterman reaction, number of things are there, but main thing about this is that what is the focus? That Williamson synthesis of ether. Now if I talk about alcohol, phenol, and ether, Lucas test and Victor test. Victor test is missing in NCERT. It is given in Tamil Nadu board, so you have to do it. And phenols ESR. In talking about ESR, very important. That halogenation, that is bromination, simple bromination or presence of carbon disulfide. And if I talk about nitration, then picric acid preparation. There are number of methods, which is the best method. So all these things you have to do. Now the very big chapter, which is very big. I hope that everyone is it visible to all of you. Aldehyde, ketones, carboxylic acid and amines, nucleophilic addition reaction. This is the main part, and all name reactions which are written over here. These are very important. Wherever their mechanism is required, the intermediates are required. You just see already I made one video whose intermediates are important. So you have to do all these name reactions and all these distinguishing tests. All these name reactions which are written over there, very important. All these distinguishing tests, you can't skip them. So just see, if it is not visible, let me make it a little bit bigger one. Now you see the visibility is proper. Now, if you want to take a screenshot, you can take. All the name reactions will come from here. If I talk about aldehyde, ketones, carboxylic acid and amines, and all the distinguishing tests will come from here. Now, next is solution kinetics electrochemistry. In solution, Rod's law, Henry's law, this is Redo. Redo is CP. Redo is CP. CP is colligative property. R for relative lowering, vapor pressure, elevation, boiling point, depression, freezing point, osmotic pressure. All these colligative properties, ideal and non-ideal. And remember that their examples are very important. For if I talk about positive azeotropic solution, negative azeotropic solution, whether the mixing of solution will make ideal solution or non-ideal, and non-ideal positive elevation and negative elevation. Now, if I talk about chemical kinetics chapter, zero order and first order, they are examples which are given in NCERT, and simply their graphical representation and T-half. That is important. If I talk about electrochemistry, then Nernst equation. Nernst equation, that the electrochemical series, if you talk about Nernst equation, electrochemical series, you should have very good command, then only you can do the proper EMF calculation. And while doing EMF calculation, the thermodynamics that will be involved, because EMF of the cell is intensive or extensive? Intensive property, right? So you should convert it into, right, delta G naught is equal to minus n times Fe naught. So anyways, then Faraday's law, and then batteries. Generally this part is missing. This time they will frame out maximum questions based on batteries. So your focus should be on batteries which are given in NCERT. Nothing else I'm asking. Whatever is given in NCERT, lead storage battery or whatever the cell is given over there. Now my dear students, each and everything I've told you. Now this is the backbone of inorganic chemistry. First, the redox. I've told you only n factor. Your focus should be n factor, then balancing you can do yourself. After that, DNF. In DNF, the main cheminophore, potassium dichromate and chromate, that they are reducing or oxidizing. They are oxidizing agents. So definitely someone will be acting as reducing agent. And if it is small, let me make it a little bit big so that everyone can see it. Now in coordination chemistry, IUPAC know very well. Everyone knows. Now the thing which we are missing, that is spectrochemical series order, that is experimentally determined. So this order you have to remember. In my lectures already I have told you the mnemonic, how to remember it and its application to find out valence bond theory, that is a hybridization. You should have very good command, because if you're not having good command, if you don't know anything about it, or you know, definitely you are having a little bit knowledge about it, definitely you will attempt the question and you will get negative marks, because without proper knowledge you don't know whether it is going to be D2sp3 or sp3d2. So take care while solving questions based on this. Then CFST, then color. This color generally people are missing. This color generally people are missing. But remember that in my lecture I have told you how to find out. scientifically color of any compound. So take care of that. Then isomerism. In isomerism, GI and OI, those 15 types of structure, M, A, B, C, D, E, F, focus over there. That the tough question can be asked from any of these things. Now, synergic bonding, you will say that is the back bonding, already you have covered in your bonding parts. That's it, kids. Take care and do let me know that definitely you're going to follow this schedule for your chemistry. This is not just going to give you marks in chemistry, it will give you marks along with chemistry as well as in physics and bio too. Bye bye, take care.